without asking an explanation of them. So you may find some patterns which show a kind of regularity which is not easy to explain, but they need not function as a kind of argument to God or design or such. But here my question is, if this is your point of departure, isn't so the concept of design somewhat confusing? Because it is an anthropomorphic concept, and as soon as you use the word design, the implication is already that there should be a designer. So if you're not, so to speak, in advance want to build in the idea of a designer, shouldn't it be better to choose another concept?
Well, yeah, I didn't really develop this whole method of design detection. I spoke about it very loosely here. And I think the important thing to keep in mind here is that what we're looking at with these patterns, and I was saying we're looking for a criterion for detecting design. I said we needed improbability and we needed some sort of pattern. Now, pattern left it, and the pattern needed to be this independently, objectively given pattern. I think at that level we still have not introduced design, because design is a causal notion. There's an intelligent agent that has produced something, and so because it's a sign of intelligence, you have then this, what I end up calling specified complexity, complex specified information. So specified complexity is this pattern improbability. Ends up being a criterion or a way of deciding whether something is designed. And so they're distinct. I mean, you have, it's much as what happens in medical testing. You have a medical test, it gives you some outcome, but then there's the question of, is the disease there or is it not? And this ontological question, is it designed, is it not? Is there disease, is it not? That correlates with this criterion. Okay, and so what you need to then try to establish is, you need to bridge that criterion with the reality. Now, in medical testing, what you try to do is, you want to eliminate type 1, type 2 errors. You don't want false positives. You don't want the test coming up positive, but then really there is no disease. Or you can also like to avoid false negatives. The test comes up negative, but in fact you do have the disease. Now, with design, with this criterion that I've identified for intelligence, you can't really get around the problem of false negatives, because intelligent agents can always mimic the effects of natural causes. So it's, or it may just be that you have insufficient background knowledge to identify the relevant patterns that point you to intelligence. And we can imagine that there are radio signals coming in from outer space sent to us by aliens, but we just are unable to decipher those messages in any way. I mean, to see any sort of meaningful pattern there, any sort of pattern that would point us to design, and so it just escapes us. And so it looks like random noise. So that's a problem that you won't be able to get around. With regard to the real issue is the false positives question. I think this is what the materialistic evolutionists will want to say, is that really it's all false positives when you attribute design. That's when you look at when you do the actual causal analysis, if you could look back at the history of life, in fact, there was no intelligent agency at work at all. It was just blind material forces. One example I sometimes give is, Johannes Kepler thought that the craters on the moon were designed. He thought that there were moon dwellers that excavated them, but in fact, these craters were formed by natural forces, meteor impacts or whatever. So there are natural ways of producing these craters, and yet he thought that they clearly indicated design. So, you want to be, you need a criterion that is going to resist false positives. I claim that my criterion does. And so then so there's some discussion. Are there counterexamples? I would say there are not. There's been some discussion about that. But it's, I think in terms of the actual science of intelligent design, it would be sufficient to look at this form of information, the specified complexity, and just work with it, and then leave aside the question of the causal story. But it's hard to separate them, because it seems that when we do know the causal story with specified complexity, with this suitably patterned improbability, then in fact it is always human intelligences, or if we have thought experiments or science fiction examples, it is alien intelligences. So they always seem to be involved there. Let me mention one other thing, because the anthropomorphism concern does come up quite a bit. I mean, what about design inferences are always one intelligence inferring the activity of another intelligence, and it requires background knowledge. I mean, just the example I just gave with the search for extraterrestrial intelligence. You have to have background knowledge. If you saw the movie Contact, this was based on a novel by Carl Sagan. There are these study researchers, the search for, looking for signs of intelligence from outer space. They get a long sequence of prime numbers that come in from outer space. It comes in as a sequence of beats and pauses. You saw the movie, I don't know how popular, it was quite popular in the United States. It was 2 beats, pause, 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 etc., all the way up to 101. So it takes about over 1,000 bits to represent that. And so this sequence comes in, and one radio astronomer turns to the other and says, this isn't noise, this has structure. They know that contact is established at that point. What if they didn't know anything about prime numbers? What would they think at that point? So there's a, so unless you have that background knowledge, now is that anthropomorphic? Well, here you've got, you might argue, well, these are prime numbers. This is built into the structure of rationality in the world. So, but what if it is something that is more closer to human artifacts? I mean, you look at the bacterial flagellum. It's a bidirectional motor-driven propeller. When did biologists figure that out? Well, it was in the 1920s. When did humans first build such machines? In the 19th century. So, but there's a coincidence there. I mean, how is it that humans are designing and building systems that later than they're discovering within biology? I mean, is it just an anthropomorphism, or is it that we're actually latching onto the deep structure of these biological systems? And indeed, we cannot even get rid of the language of function in describing biological systems. I mean, you can't get around that language. So, I'm sensitive to the anthropomorphism concern, but it is on the basis of our background knowledge and experience that we draw these inferences. They seem to be reliable. They seem to be able to transcend mere cultural sorts of accretions, but it is still one intelligence inferring the effects of another intelligence. And so, in a sense, there is an ineliminable, that you can't get around the place of the human in this inquiry. You can't just get to some sort of level of pure abstraction where there's no human or intelligence operating. So, something I struggle with myself.
Well, if there are, yes?
It was certainly a very interesting talk. You haven't mentioned your explanatory filter,
right?
Which seems to be very important in your writings. Is there a reason for that? Have you changed your mind about it?
No, I haven't changed my mind about it at all. In fact, I mean, it's the explanatory filter. It encapsulates this criterion for detecting design. I characterized it just a moment ago as specifying complexity. It's getting at the same reality. I mean, this is just more a sequential way of deciding. Well, is it the result of design? Is it the result of natural forces? So I can put it up there. I still subscribe to it. I sometimes don't put it up just because I have some critics who feel that they've destroyed the explanatory filter, and so I figure, well, I'll just put the argument in different terms, you know, and then they need to respond to what's really at stake there. Do you want me to put it up?
Can you explain it?
No, rather hear your argument, your response to the critics. Some critics have said, as far as I understand it, that it's a kind of negative argument.
Yep.
They would rather have a positive argument for intelligent design.
Mm-hmm.
The filter is some kind of ruling out possibilities and ending up with the result that then must be designed since it's nothing else.
Yeah. Well, let me put it up. I mean, it's easily done. The filter, it's a flow chart. It's a way of representing this criterion for design detection. So this is this filter, which has gotten a lot of attention. If you plug in explanatory filter on the Google search, you'll get lots of hits on it. And the idea is this. I mean, what I argue is that it's a basic part of human rationality to try to carve up the world, our experience, in terms of three basic modes of explanation: necessity, chance, and design. So necessity asks, really, does it have to happen that way? So if I, have some object in a gravitational field, it's not being acted on by other forces, I release it, it's going to drop, in the direction, in a certain direction. So there's a necessity, physical necessity in this case. And so the question, is it contingent, is just asking, contingency as it's used in this sense is something is contingent if it could happen but didn't have to happen. It means that there are live possibilities. If I flip a coin, it's a live possibility that it will land heads, and it's a live possibility that it will land tails. So there's more than one possibility. So so they ask, is it contingent? I should put a question mark here. Is it contingent is to say there are multiple live possibilities. If not, then it's the result of necessity. If it is contingent, then we ask, is it complex? Now, complex, as I'm using it here, you really want to think in terms of improbability. And I use it because this notion has some currency. It's already being used. So I could have just as well put improbability there. But think of it this way: there's a connection there. If you have a combination lock, the more possibilities on the combination lock, the more complex the mechanism is, but correspondingly, the more improbable it will be to open the lock by chance. So if there are more possibilities, greater complexity, there's more probability. So if it's not complex or not improbable, then we attribute to chance. Next thing we ask, is it specified? Does it have the right sort of pattern? It's not the sort of pattern, the movable targets, but it's the pattern that's in some sense fixed. And there's a whole theory of specifications. I mean, this idea of specification, it's actually pretty well understood in the statistical literature, where it's referred to as a rejection region. If you think of Fisher's theory of statistical significance testing, the idea is you have a chance hypothesis. You set up a rejection region, which has small probability with respect to the chance hypothesis. You draw a sample subsequent to setting up the rejection region. If the sample falls within the rejection region, then you reject that chance hypothesis. This is standard sort of statistical methodology. And it's not the only model of statistical reasoning and rationality. There's also a Bayesian approach, but this is the one that I'm adopting, and I'm arguing that it's actually more foundational than the Bayesian approach. But anyway, so is it contingent, is it complex, is it specified? In that case, we say design. So really, it's similar to what I was just saying earlier. You can think of another picture. Specified complexity, and then design. So imagine all the designed objects in the world, and those that are complex and specified, those that have this mathematical empirical property fall within the designed objects. This is a causal category. This is a mathematical, logical, empirical characteristic of certain objects. Okay. So in a sense, this picture corresponds to this picture. Now, the question that was posed is, well, isn't this a form of really negative argumentation or an argument from ignorance? So what you're doing is really you're eliminating chance and necessity, and then you're saying, well, and therefore it's design. And I would say, that I think it is an argument by elimination, but I would say it's not by pure elimination. I think for one thing, when you start asking, is it specified, you're asking for a pattern, is an objectively given pattern that you're bringing to the table on the basis of your past experience. And I think just if you start working with some thought experiments, I think you'll find that it's not just an argument from ignorance. It's that you are eliminating, but by supplying the appropriate pattern that in conjunction with complexity eliminates these, you actually are getting a positive case for design. How might we see this? I think, what sort of example do I want to give here? Let's take. Let me just throw out some examples of the sort that got me thinking along these lines initially. I wrote a book, and this is actually my first book. It was called The Design Inference. This was a technical monograph on how to detect design. And this is where I first proposed this explanatory filter. And what I found was, I was trained as a probabilist. I did a lot of statistics. And so I was aware of these statistical methodologies. And usually the way it operated in statistics when you were doing statistical significance testing is that you were trying to eliminate a chance hypothesis. And so it was along the lines that I described. You have a rejection region, you have a hypothesis, take a sample, it falls in the rejection region, eliminate the chance hypothesis. But that leaves the field open to other chance hypotheses. There are many other chance hypotheses there. What I found in practice was that there are cases where we actually have a pretty good understanding of all the relevant chance hypotheses that could be involved in the phenomenon under consideration. And that when we eliminate chance, we are in a sense sweeping the field clear of chance hypotheses. So it's not just that we've eliminated one to invite another, but that we've gotten rid of all of them. And let me just give you an example, because these are the sorts of examples that got me thinking of it as not just an elimination argument, but as a positive case. And this is one of many, but just I can sit down again. You had, there were what were called, in the old days, before calculators and computers, people used to, in the sciences, used to have to use logarithmic tables to do their calculations. Logarithmic tables at the time were computed by hand using series expansions. They're tedious to compute, but once you've done the calculation correctly, you don't need to repeat it. Now, what would happen if you, as a manufacturer of logarithmic tables, you invested a lot of research and development money in producing these tables, And then a competitor comes along, and instead of investing research and development money in also doing the calculation, decides just to copy what you've done and claim that he or she has actually done the calculations and then is also going to sell it. And in fact, be able to undercut you because this your rival did not have to invest all this money in the manufacture of this table. So how do you protect yourself? Well, what manufacturers of logarithmic tables would do is, these were usually tables accurate up to 8 decimal places, is introduce errors in the 7th and 8th decimal places and then carefully record them. And while it could legitimately be claimed by a rival that you had gotten the calculation correct, it could not reasonably be claimed that you could have gotten the same pattern of errors. Aristotle put it this way in his Ethics. He says you can get the right answer only one way, but you can err in many ways. Okay, now if you happen to err in exactly the same way, what is the conclusion? Well, the conclusion wasn't just that chance had been violated. It was, the second manufacturer copied from the first. There was a design inference that was drawn. Now you can say, there's a lot of background knowledge that we bring to bear, and yes, we do. But it was not simply an argument from ignorance. And in fact, these arguments were very compelling. They appear in many different guises. I mean, these sorts of setting traps. Computer scientists will talk about planting an Easter egg. Map manufacturers will put towns that don't exist in their atlases, so that rival map manufacturers, if they copy it, you'll be able to catch them. It seems to me that there's more than just an argument for ignorance going on there. There's an elimination going on, certainly. But the critics sometimes they put it as though, well, this is a by arguing by elimination, this is really a substandard sort of inference or argument. But it seems to me that that's not the case. It's just that it is admitting that there is an order of priority in these explanations. We will not invoke design if we can explain by means of chance and necessity. I mean, it just doesn't make sense. If somebody is 95 years old, suffering congestive heart failure, and happens to die, we will attribute natural causes. We won't look for a undetectable poison and tell a conspiracy story. Now, it's possible that that is the case, but we would then need more evidence. And so we generally, if we all get out in America, we have our coins. We talk about heads and tails. Heads will usually have the head of some president, and then tails will be the other side. It's the head of the present monarch, right? Is it the queen who's on the coins right now? And so if you flip the coin, it's heads or tails. Now, if we all got out, our heads and tails, and flipped our coins, we could get 3, 4 heads in a row, 5 heads in a row, given the number of people here. But if somebody flipped, 100 heads in a row, we would say, well, wait a second, there's something amiss here. And let me just say one other thing, because this is now moving far afield from your question, but I think it's an illustration I use which I think clarifies what I think really is at stake in these design inferences vis-a-vis biology. Imagine that we're at a stadium of 100,000 people. I don't know if you have one that size here for soccer or something. And everybody gets out a coin with the queen on one side and the tails on the other. And we can play the following game. Everybody flips the coin. If they have heads, they stay standing. If they have tails, they sit down. And you do that repeatedly. After about 17 or 18 coin flips, one person will be standing on average. The logic is very simple. 50,000 will be standing after the first, 25,000 on average after the second, 12,500 after the third. You just do the numbers, and by about 17 or 18, only one person will be standing. Now, you do not turn to the person who's standing at the end and say, what is your secret for coin tossing? You are a marvelous coin tosser. How did you do it? We say, this is just built into the nature of the system. How this whole thing, how this situation, this probabilistic setup, it's bound to happen. From the materialistic evolutionist perspective, it is bound to happen that systems of our complexity will arise over the course of an evolutionary history, unguided by any intelligence. It's the same sort of outcome. And so intelligent design is challenging that and saying it's more like somebody in the state of 100,000 getting 100 heads in a row. And that's why we need to look more closely. And so I would agree with this. I mean, that it's, I think there's an argument from elimination. I think it's more than an argument from ignorance. In fact, I think far more. But I think it requires that we also look more deeply. It means that we do need to try, after we, it is a sign of intelligence, but then the question is, how did that intelligence act? What actually happened? That the actual causal story needs to be addressed, which comes back to your concern also, because it is, if you're looking at the sign of intelligence, doesn't design presuppose an anthropomorphic story? Well, yes, then we need to try to unpack what actually happened causally. So, yeah. Okay.
Yes. Is it to this or?
Yes.
Yes. Well, I think you should ask a question.
Was not prepared and it was already now. But I want to ask you. Well, I have two questions. Maybe I don't proceed to the second question. But I thank you very much for your lecture. But I think I want to know on what level are we talking. We have a scientific level, and I think Darwinism is about science. And then you have the interpretation of scientific. And I find that your lecture and your thought is about interpretation and what happens on the scientific level. And you cannot interpret Darwinism in a atheist way. You can say there is no God, we have proof. And that's wrong. You also can keep to the thought of God and say, this is how God made it. And I wonder, are you, well, in some way, I think that you are telling God how to make the world. I think that's wrong.
Well, I speak to that. I don't see it in those terms, and I think it's not just that we're operating at this meta level, and that Darwinism is working at the purely scientific level, because I mean, there are two prongs really to intelligent design in biology. One is the critique of existing theories, and then also is trying to make conceptual space for intelligence. Now, Darwinism is a theory of process. It tells you that a certain process, certain resources, material resources, is able to affect certain changes. We ask these sorts of questions in many different contexts. I'm a mathematician. We can ask, are certain axiom systems, given certain consequence relations, adequate for proving certain theorems? And we can, Gödel proves a certain result which says that certain axiom systems, given certain consequence relations, cannot get you all true statements. Now, so we ask this question: can, given computational systems have certain properties where certain types of genetic variations operate, sifted by natural selection, is it likely that those systems, or is it highly unlikely that those systems can give rise over this evolutionary process to other systems of a certain complexity? It seems to me that's a perfectly legitimate question, and we can assess it. And insofar as we assess it, I mean, we're looking at probabilistic hurdles, because that's why I stressed, we have to be dealing with a probabilistic theory, because otherwise we can just invoke brute chance to explain everything. So there's it's not just that we are critiquing Darwinian theory, it's that we are doing these probabilistic critiques, and out of those critiques drop, as it were, the design inferences drop, because it's in showing the inadequacy of the Darwinian mechanism and other material mechanisms that intelligent design is itself, I would suggest, confirmed. Okay, now, we can argue about that, but I think we're dealing at a very nuts and bolts scientific level. I don't see it as working so much at a meta level at that point. But that is questioning the Darwinian process. Now, that then raises another set of questions about, well, what then did happen in natural history? And from a Darwinian perspective, if it is, and I'm not saying that Darwinism commits you to atheism. I don't want to give that impression at all, but it does commit you to a material process being adequate to account for biological complexity, much as the coin tossing example in the stadium, 17 or 18 heads in a row. That is bound to happen given that probabilistic setup. There's nothing magical happening. You might want to say that, well, God is behind, the whole universe holding everything together. You can make that sort of a move, but there's no real place for design, in that outcome of 17 or 18 heads in a row. Just as there isn't really within the Darwinian story, why do I have a hand with 5 fingers? I've heard Stephen Jay Gould talk about this. He said it's the result of many accidental contingencies over the course of natural history. And he has this view, if you run the video camera back and rerun the tape, get a completely different set of life forms. There'll still be life forms, but it'll be a completely different set. But what I want to come back to is, if intelligent design is right in critiquing the Darwinian process, this mechanism, then it raises the question of what happened in natural history. And it does not become a foregone conclusion that universal common ancestry is correct. Many people in intelligent design believe that it's true. But from a Darwinian perspective, that's all that could be true. Within intelligent design, there would be other possibilities. You could, in fact, there is now even scientific evidence for multiple origins. That you had that the tree of life is not one tree, but that it's a bush at the very base. I'm going on here a little bit, but I think I certainly want intelligent design to not just be work at an interpretational, this sort of high level of philosophy of science that you're talking about. Now, it wouldn't be bad if it did work just at that level. I mean, I think William Lawrence Bragg, Nobel laureate in physics, once remarked that the important thing in science is not the discovery of new facts, but new ways of thinking about those facts. And I think at some level we are looking at the same facts, but it's then we look at patterns of those facts, theories to account for those patterns, and and that's where things get controversial when there's not much consensus.
It's short question.
Well,
Better short answers to be honest.
What's the suggestion?
Probability there. Because you always compare with what we find improbable, that so many hits could go on for forever. And that's improbable to us. But then we take this human probability thought and develop it into nature, and that doesn't work. I can give you an example, because I think that what we have found in nature, for instance, in our planets, and in the surroundings of our planets, in Saturn, it's quite improbable that 2 moons should move the way they actually do. But we have found that nature is much more improbable than we thought. So I think that you are using a human kind of improbability to make your design point. And then the other question that I didn't mention before can come now: what are you thinking about design? How does design work? We know that the Darwinian theory has been fruitful for science. But how could design be fruitful for theology, for instance? Well, I don't know how to figure out what happens when something comes out by design. we figure out that God waits until the biologist looks the other way and then just has his finger? Or how can we imagine what happens? Are we bound to say that we can't explain it, that it must be designed and then stop?
Well, this is not going to allow me to do a short answer.
Medium short.
Very good. Well, let's first talk about the whole question of these probabilities. I mean, I give coin tossing examples because they're accessible. You know, they're things we understand. But they are toy examples. You know, but I think they capture something that's important. But the thing is, we can actually form some reasonable estimates in biology. I mean, not all probabilities. I mean, coin tossing example, the probabilities there, they're equal probabilities, independent, identically distributed random variables, and you have an object that's symmetric, so you know what the probability there is. But in standard scientific practice and experimentation, what you need to do is compute empirical probabilities. You know, and there, I mean, you actually can get some pretty good estimates for the sorts of probabilities that come up in biological systems. If you look at the DNA, for instance, you know, the DNA bases are attached along what's called a sugar-phosphate backbone. So there's total degrees of freedom in terms of how they can be arranged. And it's essentially, you know, if you just were to put these things in a vat, you know, they would arrange pretty much independent, you know, insofar as they could be arranged along a sugar phosphate backbone. There are no bonding affinities that are forcing one thing to be closer to another. It's like if you have a refrigerator and magnetic letters there, they can be arranged pretty much any way. So if there is something that's arranging those letters, it is some other constraints, some external constraints. It's not something that's built in. Okay. Now, those constraints, though, let's say they're arranging letters in a certain way. The letters allow full degrees of freedom. When I'm talking letters, I'm talking about the DNA bases. So any constraining conditions must also, in a sense, allow degrees of freedom. If one set of constraints gives rise to one DNA sequence which codes for one set of proteins, then there could be other constraints that code for other things. So what I'm saying there is, I think we have a pretty good grasp of the probabilities that are involved in sequencing DNA. And we can look at other empirical probabilities that are involved. Now, question, is it that highly improbable things happen all the time? And you mentioned the moons of Saturn. Well, yes, I mean, I gave the example with the coin toss of 1,000 heads in a row, but are we talking about specified improbability? Is there an independently given pattern there which is being matched? That's what's not so clear to me with these moons of Saturn. I mean, there are many coincidences that after the fact strike us as quite remarkable, but it is, being able to, I was at a debate at UCLA 2-3 weeks ago in which a fellow named Michael Shermer, he's a noted skeptic in the United States, he wants to argue that really humans are pattern-seeking, narrative-telling animals, and so they're going to find patterns all over the place. And so he gives the example of, finding some patterns in the clouds, or seeing the Virgin Mary in some, some window or something. He's got an example in apparently some sort of soap. There's some window where there's some soap applied and led to some image that looked like the Virgin Mary. There's now even a shrine in this church or a car wash or whatever it is in Florida. So, but the thing is, this is to me wish fulfillment. I mean, it's and these patterns, they're imposed after the fact. It seems to me that I've got a theory that actually allows me to distinguish those sorts of patterns from other patterns. So, so this is being much discussed now, but I want to avoid these sorts of improbabilities where it is just we're bringing our own background baggage to bear, and then we're just finding what we want. Okay. So I think it is possible to get around these sorts of improbabilities and to work at a level where we are being fair and faithful to the biology and not just employing toy examples to somehow justify something that really won't hold up. So that's, I think, the first question. Now, the second question, with regard to Darwinism has been fruitful in biology. What does intelligent design bring to the party? Is it going to help us gain some insights? I think it is already. I mean, I think if anything, it is helping to make Darwinian theory more honest. I mean, there's some very prominent people who are saying this is important. I mean, what we're doing. They don't think it's going to pan out in the long run, but they think it's important for science to be subject to this sort of criticism. I mean, people who come to mind are David Raup, well-known paleontologist at the University of Chicago, member of the National Academy of Sciences. He wrote one of the key books about extinction and of the dinosaurs. Paul Davies will say that this project of design detection, these mathematical criteria, this is important, and he wants it to get fair consideration. I think it's important not to exaggerate the success of intelligent design. I think we're a fledgling program. I think we have our work cut out for us, but I also don't think it's wise to exaggerate Darwinism's accomplishments. I mean, I think it's been certainly Darwin's notion of natural selection is very useful. I mean, it's very important in many contexts. I think but where it has been best confirmed is at for small-scale evolutionary changes. I mean, I don't see any confirmation of large-scale changes where you have new organ systems, fundamentally new structures emerging. You have antibiotic resistance in bacteria. I think this is a very important phenomenon, especially with the overuse of antibiotics. So I think it's and I think it's actually been very fruitful in computer science with the whole field of evolutionary computation. But I think it's very important there to keep in mind that evolutionary computation is itself design intensive. I mean, there's an engineer at Boeing, the competitor of Airbus here, right, who will call himself a penalty function artist. Okay, it's when you're designing, and I say designing evolutionary computational systems, one of the most important things is to set up your objective function. You're trying to get an objective. You have to set up, an objective function which will guide the process to its goal, to the target. And that's very intensive, design-intensive work, getting the right objective function, or fitness landscape, or penalty function, call it what you want. But, so yes, I think Darwinian theory has been fruitful, but I think temptation in science is always to take an idea and try to expand it beyond its natural domain, to totalize it, explain everything. And so you have, I think, what are really ridiculous claims by people like Daniel Dennett, hyper-Darwinist in the United States, where he will say Darwin's idea is the greatest idea ever conceived, far ahead of Einstein and Newton. Well, I don't see that. I think it's a good idea, but I think it has a limited scope. But for hyper-Darwinians, it explains everything. And so you have a novelist, Barbara Kingsolver, who will write that this is the greatest idea ever considered, and it explains everything. Something it doesn't.
Jakob.
Well, actually, we've passed the point because it was about the critique of this explanatory filter, but maybe I can just make one short, quick comment on it, because this critique that it's only eliminative, and when you answer, well, what is left is design. My comment would be, or question would be, is, well, there could be other possibilities that we just don't know yet, or maybe there are other possibilities. And this raises for me the question about, is this that the design, to claim that design is what is going on, is just an analogy. Because I would like to introduce the analogy problem here. Actually, I don't want to say just an analogy, because it's a very, very, very good analogy. But still, it raises the question about, is this an analogy, or is is it a total adequate point to make that this design is the only?
Well, I think one thing, one way that I think this filter has been misinterpreted is though when you look at the end outcomes, that these have to be mutually exclusive and exhaustive, and I don't see that at all. I think what usually you're doing is you're feeding in some aspect of a system. So as I gave the example with the human genome, I mean, there could be aspects of it that are designed and aspects of it that are the result of natural history. And so what you're going to have to do is you're going to have to focus on the relevant aspect and feed that into the filter. If you're looking at a rusted automobile, if you're have a microscope focused on some rust, that's the effect of weathering, natural causes. You're not going to see design there. So I think all of this gets mixed together, can get mixed together, but what is the relevant feature? What is the feature that you're focusing on? That's what gets put into the filter. Now, can the filter go wrong? Well, yes, it is fallible in the sense that if you don't know what all the relevant probability distributions are, then you can miss it. So, but that, it seems to me, is not a strong criticism of the filter. I mean, it's a problem that's endemic to science generally. I mean, if you're missing some of the relevant background knowledge, when you bring that in, anything could happen. So it could be that turn it around. It turns out, you do an analysis, a design theoretic analysis, you conclude that some feature is the result of design, then you find that in fact, that if chance was operating, or if purely natural forces were operating, there was some other probability distribution, but it makes it still that much more improbable that it would have resulted. Now suddenly your design inference is that much stronger, So it could work that way. But I think that's just a problem that you're going to have generally. But then and this is, Jakob has a book on intelligent design that's coming out, which looks very nice. I just scanned through it. It's got a wonderful cover, so this is artwork expressly created for it. But one of his concerns is that when you draw these design inferences in human contexts, you are doing something that's entirely legitimate and non-problematic, but then when you apply them in case of nature, that really you're working with an analogy. It's no longer information there is something that's analogous to human information, but it's not the exact thing. And so maybe I should let you describe it because I don't want to misrepresent it. But I think that the concern is that if intelligent design, when it's finding design in nature, is operating analogically instead of finding, what I want to say is that the specified complexity in nature is identical with the specified complexity in human contexts. If it is only an analogy, then perhaps design will operate more as a regulative principle for science. It will help us in guiding research, but it won't actually enter the content of science. And so this is, I think it's an interesting point. And a lot of this also then hinges on even the nature of science, the demarcation problem, what belongs in science, what doesn't. And I think this is one of the issues that intelligent design is raising. What is the nature of science? What modes of explanation are permitted in science? And if you go back 150, 180 years to Laplace with his notions of determinism, it's in his essay on probabilities that he proposes what's called this Laplacian demon, this intellect that by knowing what all the positions and momenta of particles are at a given moment can predict the future with absolute certainty and retrodict the past with complete certainty and knowledge. Well, that picture of the world is dead, but he writes this in an essay on probability. So his conception of probability there is really that it's that probabilities are things we introduce because of our ignorance of the precise deterministic properties of the world. But I think with the rise of quantum mechanics, statistical mechanics, chaos, but especially quantum mechanics, I think the sense that there's a fundamental randomness inherent in the world is much more, we've become much more open to it. And so chance does become again, a causal mode, a mode of explanation that was not legitimate. But you know, we're finding now with multiverses, which give you a vastly greater ontology, but recover determinism in physics. You know, this whole approach to understanding quantum mechanics and quantum indeterminacy in terms of, you know, many worlds hypothesis. You know, it's very, very popular among cosmologists. So, you know, so intelligent design is saying that we should treat intelligence as a fundamental mode of causation on that order. Well, that's raising a whole question about, you know, what the nature of science.
Yeah, people have been born with 6 fingers and 6 toes. I have seen one. I think you try in a logical way to prove God, and this is in my head to do something smaller to prove something unlimited, something limited to prove something that is unlimited, and this I find questionable in itself. And then you use the example of cars and houses that they are not alike. That's the difference. So I find this similarity also questionable. And you say intelligent design, and the word intelligence points to something that is invisible in itself, because it means that which is between the lines. That is the way it means that.
Okay. Good. Let's. I think what was your first concern about proving the unlimited, or you know, just this whole project of trying to prove things about God as a result of intelligent design. I tried to stress, and you know, maybe I needed to do it more, that as a scientific project, it's very limited what intelligent design is trying to do, which is show that there's some form of intelligence behind what we see in biology. You know, I didn't mention God. I mean, I did, I suppose, in trying to contrast intelligent design with creationism, but it's not a doctrine of where things came from. God, certainly, I think in this context where we're discussing, God is the source of being of all things. So. I think it's much more modest program that I'm trying to get at. That there's an intelligence, a purposiveness behind things. And you raise that in the context of somebody having 6 fingers. You know, designs go awry. I mean, drugs that are meant to alleviate pain get used, you know, and become sources of addiction. You know, I mean, implements that are meant to better human life become torture implements. You know, you know, I don't. You know, I'm trying to get at design as such, not at, you know, judgment about the nature of that design or the ultimate source of that design. I think the question you raise about, you know, I give examples of construction sites, houses, bacterial motors. I think it is legitimate to use those sorts of examples, but perhaps I should have said that I don't see life as fundamentally mechanical. But there's no contradiction there, though. There's this a common fallacy in logic known as the compositional fallacy, which is to say that because something is composed of pieces that have some feature, therefore the totality has that feature. I think it's evident, if you look at the subcellular level, that there are molecular machines there. I mean, there's special issues of various journals now devoted to molecular machines. They are in the cells. They are machines. But that doesn't mean that the cell is a machine. It doesn't mean that organisms composed of cells are machines. It is just that these are the most tractable features of these systems. You know? So if we can establish design there, again, I'm going to come back to this. I don't need, as a design theorist, to establish that every aspect of biology is design. I just need to find some clear instances. And if I affirm that the bacterial flagellum is design, I can then affirm that the supersystem in which that design system is embedded is also design. But in affirming design of the cell, I'm not saying that it is a machine. It might be a machine, but it need not be. I don't think it is a machine. I think, so I don't want to push that fallacy. I think, and so I think we're on the same page. That life is not. It's not. Life does things that no machine